Okay, here's another example of a proof where you have been given parallel lines, but you're also proving lines parallel. So this is number 3 on your worksheet. And what's different about this one than the last one we worked on, although we're still trying to prove lines parallel, is that our other given information here is that we have angles supplementary, not congruent. So if you watched my last video for number 2, the one thing I said that I try to stick with congruent statements if I can. But in this one, since we're given supplementary, I am going to have to somehow deal with that. So this one's going to be a little bit different as I work through it. And there's actually 2 really good ways to do this proof. I'm going to go with the way that I think more of you would do it, but then I am going to show a shortcut. So if you want to see the shortcut, stay tuned because I will show you like a shorter way to do this where you can cut out quite a few steps. Okay, I think I've got my given information down. Angle 5 and angle 14 are supplementary. I'm just going to pick those out in my picture. 5 and 14, not an angle pair if you think back to chapter 1. So significant to know because I wouldn't know that based on lines being parallel. And as I said in my other video, you have a ton of things that you can say. Just based on knowing L is parallel to M, I could list out at least 20 things I know are true. But we're going to try to avoid that. So let's see if we can be as specific as possible and direct as possible to try to get to P parallel to Q. I might work backwards at some point, but I'm going to start by using my given information and turning it into an equation because I like to work with equations. So directly from my given information right here, if angle 5 and angle 14 are supplementary, then I know that the measure of angle 5 plus the measure of angle 14 equals 180 degrees because that is my definition of supplementary. So nothing crazy, you guys have done that before. And let's see what we could do with that. Okay, so we're trying to prove P is parallel to Q. That means that I can, sorry, trying to straighten this out here. That means that when I look at my picture, since L and M are parallel, these are my parallels, I can make conclusions about these angles, or I can make conclusions about these angles here. Because that's what I'm really just using half my picture then. So either that or that. I cannot make conclusions here or here because that would be using P and Q parallel, which is what I'm trying to prove. So I'm going to try and see if I can replace either angle 5 or angle 14 with something to get a pair of angles that are supplementary that would allow me to say P and Q are parallel. So at this point, I'm thinking backwards, and I'm thinking that in order to say P is parallel to Q, I have a whole bunch of converse theorems. But the one that I'm focusing on is the only one that involves supplementary as opposed to congruent relationships between angles, and that would be your consecutive interior angle converse. So if you need to take a minute, look at your theorem sheet. The consecutive interior angle converse theorem tells you, and I believe that that is number 17 on your sheet. Yes, that's 17. It tells you that if you have a pair of consecutive angles that are supplementary, consecutive interior angles, then you do know that the lines are parallel. So I'm looking right now, well, 14 is a consecutive interior angle with 3. 5 is not a consecutive interior angle. And again, I'm limiting myself to just looking at either 5 or 14. So 14 and 3 are consecutive interior angles. If we jump down here, I'm thinking right now, hey, wouldn't it be cool if we actually knew angle 5, not angle 5, angle 3 and angle 14. Are supplementary. Now, I don't have a way of justifying this right now. I'm just thinking that if I knew that, then I could jump to P is parallel to Q. One more time, let's look at our picture. 3 and 14, consecutive interior angles. If they're supplementary, then I know that the lines are parallel because that would be my consecutive interior converse theorem at the end. Okay, so this is just totally me trying to set up a proof that would work out nicely, but I don't know if I can get there. Let's see if I can. Let's go back one more step. So if I know angle 3 and angle 14 are supplementary, or in order to know that, I would need to know that their measures add up to, you got it, 180 degrees. So I'd like to get to there. If I get to there, oops, I forgot my angle symbol, then I would know that angle 3 and angle 14, so if I can get to here, then angle 3 and angle 14 are supplementary, and then the lines are parallel. Well, now I've got two equations to work with, or an equation I have and an equation I want to get to. Let's do some looking at step 2 and then my proposed step down here. And notice that we have 180 here. We have angle 14. And the only thing that happened is angle 5 became angle 3. Well, in order to replace angle 5 with angle 3, what do I have to know is true about the two angles? Yeah, I better know that they're equal to each other. So let's look at our picture. What do we know about angle 5 and angle 3? Are they equal to each other? Can we say that? And if we're looking at angle 5 and angle 3, you should be recognizing that we have an angle pair there. Now be careful. Is that legitimate to say angle 5 and angle 3 are equal or congruent? And we have to note that we have L parallel to M. So because L and M are parallel, I'm using these angle pairs. That is okay. I'm not using P and Q there. In fact, Q is not even a part of my picture. I'm only using that top half of my picture. So that's going to be my next step, is to go ahead and make a congruent statement. I'll try to keep that on the page. So my next step is going to be that angle 3 is congruent to angle 5. And hopefully you're seeing that those are alternate interior angles. Not converse, because I'm not saying lines are parallel. So that's my original theorem. If L is parallel to M, then angle 3 is congruent to angle 5. So I'm going from my given to step 3 to make that statement. I'm almost ready to get to where I left off in my thinking, but I am going to add one more step in here, and this is one of those picky steps that we should be saying, not a huge deal in terms of the overall logic of the proof, but before I substitute in, which is what I'm about to do, I should say that their measures are equal using my definition of congruent angles. So I'm going to throw that in there, and then I'm going to move this up and go ahead and number my 3 steps I had proposed, and let's see if I can justify all of them. So step 5, there's where I did my substitution, substituting angle 3 for angle 5 because I just said they're equal to each other. Note that could not be transitive property. I know a lot of times we can interchange those, but that's one of those that has to be substitution. Angle, or step 6, is then going to be what? Take a look. I'm going from 5 to 6, so if you like to phrase them as conditional statements, if the measure of angle 3 plus the measure of angle 14 equals 180 degrees, then angle 3 and angle 14 are supplementary. You should be getting definition of supplementary angles. I know a lot of times we use our definition the other way. In fact, we did right up here, we said if angle 5 and angle 14 are supplementary, then measure of angle 5 plus measure of angle 14 equals 180 degrees. That's the direct opposite. I knew that the angles were supplementary. I concluded 180 degrees by my definition. And now I know that they equal 180 degrees. I conclude that they're supplementary. My definitions work as biconditionals. So all I did is exchange the hypothesis and the conclusion in those cases. And the last step, I know the lines are parallel because of my consecutive interior converse, because right here I had consecutive interior angles. I stated that they were supplementary, and then I use them down here to conclude. If that's true, then I know the lines are parallel by my consecutive interior converse. Hopefully that helps. I'm going to encourage you to try one on your own. I would say that give me a second to find the right page. I believe on the back side, you could do a similar process for number 5 on the back side. I did say I was going to show you a shortcut. I'm going to make that another video so I can clean up my pictures. So if you want to watch a shortcut video, I'll post that one in just a second.